Hello everyone. This is Professor He. Nice to see you again. The topic of this task is about the evaluating Gibbs function. Changes in Gibbs function and entropy are among the desired quantities in thermodynamics. As we will discuss in the next task, if changes in Gibbs function is negative for a mixture of gases, then mixing and/or a chemical reaction would be spontaneous. Otherwise, if changes in Gibbs function are positive, they cannot happen. There are two ways to evaluate the changes in Gibbs function. Now, let's first talk about the method A. As one of the thermodynamic properties, the Gibbs function plays a very important role in dealing with exergy analysis. For the reacting system, we have the changes in Gibbs function by definition as shown by equation 1366. The changes in Gibbs function is simply the difference between the Gibbs function of the reactants and that of the products. The evaluations are based on the enthalpy and the entropy, and we need reference state. The reference state for enthalpy is the standard reference state, that is 25 degrees centigrade and 1 atm. The third law of thermodynamics provides an absolute base for the entropy values for all substances. Entropy values relative to this base are called the absolute entropy. The absolute entropy can be determined based on the absolute entropy and the standard reference state of 25 degrees centigrade and 1 atm. From the TS diagram showing the relations for the states, we have the absolute entropy expressed as, this is equation 1367. Using the second DS equation, equation 532, equation 1367 can be rewritten as equation 1368, where CPm is the specific heat on a molar basis. The second term of right-hand side of equation 1368 is the entropy change isobarically from state T0, P0 to state T, P0, which is determined by the second DS equation, while the third term of right-hand side of equation 1368 is the entropy change isothermally from state T, P0 to state T, P, which is determined by the second DS equation from ideal gas. Till now, the changes in Gibbs function can be determined by equation 1366. We now talk about the second way, method B, to evaluate the changes in Gibbs function. The changes in Gibbs function can also be evaluated based on the Gibbs function of formation. Gibbs functions for the reactants or the products can be expressed by the Gibbs function of formation at 25 degrees centigrade and 1 atm, where G F0 is the Gibbs function of formation. The values of several substances are listed in Table A12. Therefore, the changes in Gibbs function for the reacting system are. This is equation 1372. Okay, that's all for this task. Thank you very much, and see you next time.